Hi, I'm John Derry, Senior Application Engineer at Promess Incorporated. Today we'll be wrapping up our software basics portion of the EMAP series of videos. So far, we've discussed building a program from scratch, as well as different methods you could use to press your components together. Today we'll be taking a deeper dive into creating a monitoring strategy, which will help you determine a good part from a bad one. The first thing we like to do when we work with customers to help them develop a monitoring strategy is take a look at their part print. Usually there'll be a couple callouts such as maximum force, final position or depth, and maybe a force before shouldering. We'll cover those today, as well as a couple other things you could use that might help you determine a good part from a bad one. So now looking at the UltraPRO software, the first thing we're going to do is add a maximum Y function. This gives us the peak force that has been achieved during the press cycle. We will also add a maximum X, which will give us the final position or maximum position that is seen during that press cycle. Once we have both of these added, generally next we'll add a window. Today we're going to anchor this window off of the end of cycle. This allows us to be more dynamic and accept different parts with different tolerances and have the window shift with that final position. In today's example, I'm going to be looking about 20 millimeters back from final position and ignoring the first quarter millimeter. This allows me to get a true indication of the interference fit of these components without looking at the shouldering. Within my window, I'm going to look for an average force, as well as apply some relative upper and lower limits. If our curve that we collect exceeds either the upper or lower limit, we will determine that it is a bad part. Another tool that our customers like to use sometimes is what we call a Y-cross. The Y-cross allows us to input a force value and it outputs a positional value. We can then use that position to determine how far did we press the component into the receiving component. In today's example, I'm going to look for a position at 20 newtons. So I'll go ahead and save that over to the UltraPRO controller, go back to my HMI and press cycle start. So we can see we're applying load to this spring and we should shoulder on the hard stop outside of the spring. This simulates pressing to a shoulder. Okay, now we can see that our data has been collected. So if we hover over these arrows at the right side of the screen, we can see that we have final position indicated, as well as peak force indicated. We can see our upper and lower relative limits indicated, as well as our average window force indicated. We can also see on the lower left-hand side, we have our Y-cross or touch point indicated. There are numerous other additional tools that we have in the UltraPRO suite. If you'd like to learn more about these and learn how we could help you develop a monitoring strategy, please feel free to reach out to us. Our engineering team would love to speak with you. 810-229-9334 or visit us on the web at promessinc.com. Thank you for watching.